Okay, last time we introduced the inverse trig functions, and by far the most important thing in that previous video was the fact that we talked about the range of the inverse trig functions. When you take the inverse sine of something, you'll always get an angle between negative pi over 2 and pi over 2. So that means you'll always get an angle in either the fourth or the first quadrant, right? Between negative pi over 2 and pi over 2. When you have when you take the inverse cosine of something, you'll always the range of the inverse cosine will always be an angle between 0 and pi. So when you take the inverse cosine of something, it always puts you either in the first quadrant or the second quadrant, right? 0 to pi. And with the inverse tangent, when you take the inverse tangent of something, the range of the inverse tangent is between negative pi over 2 and pi over 2, but remember, it's an open interval, okay? Puts you in the first or the fourth quadrant. So that helps when you're trying to compute these things. Anyway, let's keep on going here. So suppose you wanted to compute some of these inverse trig values here. First of all, it turns out the inverse sine of 5 is undefined. Now, why is it undefined? Well, the inverse sine of 5 is the angle whose sine is 5, right? There is no angle whose sine is 5 because the sine is always between negative 1 and 1. Now you could find an angle whose tangent is 5, though. That's what inverse tangent of 5 means, right? In fact, if you notice on your calculator, inverse tangent of 5 in the degree mode, you get 78.7, about 78.7 degrees, approximately. Anyway, let's keep on going here. So, how about this one? You want to find the cosecant of the inverse tangent of negative 1 over radical 3. Well, remember, we're going to do this first. Let's think of this as an angle. Isn't this an angle in either the fourth or the first quadrant whose tangent is negative 1 over radical 3? So we got to be in quadrant 4. It might look something like this. This is one of our known angles. Most of these ones on their homework turn out to be known angles. Your angle is this one right here. So let's see. You could think about it as this as being negative 1/2, this being radical 3 over 2, this is 1. So what angle is that? Isn't that, turns out it's negative pi over 6, but you don't even have to know that. You know why? Because now that you've drawn your picture, what is the cosecant of that angle, theta? The cosecant is 1 over the sine. The sine's negative 1/2 over 1, so the cosecant's negative 2. You see, I never really used the fact that it was negative 30 degrees, did I? Or negative pi over 6. And here's a good example of what I'm talking about. Here, you don't really know this angle. This is not one of our known angles, but you can still draw a picture. Think of this inverse tangent here as being some angle theta. It's the angle whose tangent is 2/3. So we're in the first quadrant, right? Tangent is 2/3. So you could call this a 2 and this a 3. By the Pythagorean theorem, this comes out to be square root of 13, I think. So even though we don't know what this angle is, we could find it, but we don't need to know. It's the sine of that angle. The sine of that angle would have to be 2 over square root of 13, right? Okay, I know what you're thinking. You're having so much fun. You just don't want to stop, do you? I thought so. I am too. Well, let's look at some more. Let's find the secant of the inverse sine of 3/5. Remember what this is? This is the angle whose sine is 3/5. It's the angle between negative pi over 2 and pi over 2 whose sine is 3/5. So it has to be in the first quadrant. I'm trying to think of an angle whose sine is 3/5. Again, it's not one of our known triangles. Let's see, this is theta. But you could use the Pythagorean theorem to find x. Let's see, x squared plus 3 squared equals 5 squared. Oh, we know this one. X squared equals 16. So x equals positive 4 because you're in the first quadrant. So anyway, again, so you do need to know that. It turns out x is 4. So this is the secant of theta, right? So what's the secant of that angle? It's 5 over x, so it's 5 over 4. Drawing a picture seems like a good idea to me, doesn't it? Seems like a really good idea for many problems. Okay, let's keep on going. I want to find the cosecant of the inverse tangent of 5. Again, think of this as theta. The angle in the first quadrant whose tangent is 5 would have to look kind of like this, right? I'm thinking of an angle in the first quadrant. Could you think this is 5 over 1? Then the hypotenuse, I believe, turns out to be square root of 26. So I don't know what this angle is. I don't need to know. It's just I want to find the cosecant of that angle, right? So the cosecant, whoops, what is that? Let's try that again. Cosecant. So that turns out to be, let's see, 1 over the sine, right? So it would be square root of 26 over 5, right? Okay, let's keep on going. How about this one? This is kind of sneaky. This is the sine of 2 times the inverse cosine of 2/3. Okay, let's think of this as 2 theta here. Let's first find out what theta is. Theta is the angle whose cosine is 2/3. So we're either in first quadrant or second quadrant. I imagine we're probably in the first quadrant here. Cosine is 2/3, so how about a 2 and a 3? And then to find y, I think this is theta. Let's see, y squared equals 3 squared minus 2 squared. So y squared equals 5. Y equals the square root of 5, right? Alright. We do need to know that. So it's the sine of 2 theta. Well, the sine of 2 theta, remember, is 2 sine theta times the cosine of theta, right? Alright, well, the sine of theta is y over 3, so it becomes square root of 5 over 3. And the cosine of theta is 2 over 3. So let's see, the answer, when you multiply that out, you get, let's see, 4 radical 5 over whoops, what did I do? 4 radical 5 over 9, right? Alright. Okay, these last ones are pretty hard, I should say. Look at number 8. It says you want to find the cosine of the inverse sine of 1/3 plus the inverse cosine of 1/3. Here's a hint on this one. Think of this as the cosine of a plus b, where we have these two angles, a plus b. And you know there's a formula for that, right? Cosine of a plus b equals cosine a cosine b minus sine a sine b, right? So here's what we're going to do. We're going to draw these two angles. Well, what does angle A look like? It's the angle whose sine is 1/3. So let's see. Angle A might look like this. Let's see. How about if you call this 1 and this 3? Isn't this angle A? So this side right here, call that x, would have to be x equals the square root of 9 minus 1. X equals square root of 8, right, which is 2 radical 2. Now for B, let's go down here. B is the angle whose cosine is 1/3, right? So let's call this angle B. So this would be 1, and this would be 3. And then in this case, y would equal the square root of 8, which is 2 radical 2. Okay, so then we can start plugging this in. Look, if you draw your pictures, be careful about this, you can start plugging stuff in here. What is the cosine of A? The cosine of A is 2 square root of 2 over 3. What is the cosine of B? Cosine of B is 1/3, right? Minus the sine of A. The sine of A is 1/3. And what's the sine of B? It's 2 radical 2 over 3. So what do you get? That's interesting. Don't you get 0? Yeah, you get 0. Amazing. Anyway, let's do another one. This one's kind of interesting. You want to find the secant of the inverse tangent of x. The instructions would probably say express your answer in terms of x. Okay. So, well, x is just an unknown. But again, think of this as an angle theta. Think of this as theta. I want to try to draw an angle whose tangent is x. Well, let's see, if this is theta, couldn't you call this x and this 1? Right? Isn't the tangent of that angle x? So by the Pythagorean theorem, this becomes x squared plus the square root of x squared plus 1, right? Alright, so what is the secant of that angle? It's the secant of theta. Secant's 1 over the cosine, right? So wouldn't it just be the square root of x squared plus 1? So that's kind of interesting. Alright, let's do one more. On this one, same idea. It's kind of a combination of the last two. I wonder if the answer is 0. That's interesting. No, it's probably not going to be because you have a sine here. But remember the formula for the sine of the sum of two angles? The secret is, let's think of this as angle A, this angle B. What is the formula for the sine of A plus B? It equals sine of A cosine B plus cosine A sine B. So this is what we're going to do. We're going to find these two angles. Angle A, remember, is the angle whose cosine is x. So let's draw a picture here. I don't know what x is, but you could call this x and this 1. Doesn't this angle A have cosine x? So then by the Pythagorean theorem, this would be the hypotenuse squared minus the square of this, square rooted. So the y coordinate would be square root of 1 minus x squared. Now for this angle B, it's the angle whose sine is x. So let's just draw this angle like this triangle here. The sine would be x, so this would be x, this would be 1, and again, then this side would be the square root of 1 minus x squared. So let's just plug it in. It's equal to the sine of A, which is the square root of 1 minus x squared, times the cosine of B. Cosine of B would be the square root of 1 minus x squared, plus the cosine of A, which is x, times the sine of B, which is x. So what do we get? Well, this is nice. Look, we get 1 minus x squared, right, plus x squared. Final answer is 1. What a nice answer. Alright, I guess we're done here. We'll see you later. Bye-bye.